Today we are presenting our College Quarter Biofiltration and Reuse Capstone project. In College Quarter, there are plans for future developments to enhance the U of S campus. Urbanization of a previously undeveloped area will increase the stormwater runoff volume. Therefore, there's a need for a stormwater management site to store and filter the excess runoff while allowing for water reuse opportunities. To determine the stormwater storage capacity, the area was modeled using the EPA's stormwater management model for a 100-year, 24-hour design storm. To accommodate for climate change and future developments, a safety factor of 1.5 was applied. From this, a required volume of 11,000 cubic meters was determined. For this project, the objectives were to reduce municipal storm sewer loads, incorporate a biofiltration system that will remove solids and contaminants from the stormwater with minimal maintenance, and develop a naturalized space that enhances recreation, supports habitat functions, and provides educational opportunities.
To manage stormwater in College Quarter, 3 designs were considered. The first was a detention pond, which is an area with gradual slopes where water can collect after a storm until it infiltrates through the soil. To allow for stormwater reuse opportunities, storage tanks would be installed underground. A retention pond was also considered. This structure holds a permanent pool of water while containing a runoff following storm events. Lastly, a constructed wetland was investigated, which has fluctuating water levels with the addition of shallow marshes, making it a suitable environment for the growth of aquatic and semi-aquatic plants. The constructed wetland was chosen as the design as it best addressed the project objectives. Benefits of a constructed wetland include reduced flooding risks, improved water quality, wildlife habitat and biodiversity, nutrient cycling, and recreation and education. This is our constructed wetland design. After a storm event, the runoff from College Quarter will enter a vortex separator before it is directed into the wetland. Next, the stormwater will flow through alternating zones of deep pools and marshes before it reaches the outlet, where there's an opportunity for water reuse.
First component is a vortex separator, which is an underground system that removes coarse solids and floating material using cyclonic forces. Sediment can easily be removed by a vacuum truck with minimal operational costs. Next, the water flows through alternating deep and shallow zones. The deep zones increase detention time and allow for aeration of water, while the shallow zones have a dense cover of vegetation that act as a media for filtration and bacterial growth. Within the deep zones, floating wetlands islands will be added, which are mats of vegetation. The water flows through the root zones, allowing for more filtration and nutrient cycling. Surrounding the wetland is a vegetative buffer, which provides erosion control. Once the water has traveled through the wetland, it can be pumped out for irrigation use, saving costs for the university. A drainage channel acts as an emergency outfall in the event of flooding. To address public health and safety concerns, a raised, fully accessible boardwalk and a walking path with railings separates the public from the open water surface. Signage will also be installed in the wetland. The total cost for the constructed wetland is approximately $1.1 million. Materials make up the majority of the cost, since the labor can be completed over the course of one construction season.
The constructed wetland provides several environmental benefits. Stormwater collected in the municipal sewer system typically enters the South Saskatchewan River without any treatment. By collecting and treating stormwater on site, river water pollution is decreased. The wetland is a naturalized space that provides ecosystem services, such as a wildlife habitat for birds and amphibians. Using reclaimed water on campus for irrigation can save the University of Saskatchewan from using treated water, therefore being an efficient use of water that would otherwise serve no benefit. Native wetland vegetation will simulate a natural environment and increase plant biodiversity. In addition to environmental benefits, the wetland provides social benefits. As this wetland will be part of the university campus, it can serve as a research and study area for university and grade school students. Having features such as accessible boardwalks and pathways promotes community involvement and recreation. Informative signage throughout the wetland can help educate the public about the importance of natural ecosystems. Thank you for watching our presentation.